Okay, so this next one has to do with the big property in a hyperbola. Okay, so just to contrast, there's the hyperbola and there's the ellipse. So when we looked at an ellipse, if I took the distance from P to G and I added it to P to F, if I added those two distances, I get the length, I get the distance between the two vertices, which in this case is 20. So PF plus PG equals K. K would have to be 20 when you add those. Now, when you do it to an ellipse or to a hyperbola, you don't add them to get the distance between the vertices, you subtract them. All right, so in this case, the distance from P to F, which is 2, and the distance from P to G, which is 8, since this is a hyperbola, if I subtract those two, I'm going to get the distance between the two vertices. So this length right here, guys, from there over to this vertex, is going to be the difference of these two numbers. So 8 take away 2 is 6. And then the question's asking you, well, what's A then? Well, if the whole thing's 6, then A has to be 3. And that's what you do when you have a hyperbola. Okay, number 6. You're told that you have a hyperbola, and the two focal points, these focus points are on the y-axis. Okay, so what I did over here is I cut and pasted the properties from lesson 8 for when you have when the focal points are on the y-axis. Okay, that's these guys right here. I know it's a little small, but that's what you're going to be using to solve this question. Okay, all right. So the first question is asking you, what are the coordinates of A? Okay, so in my drawing right here, these are the two focal points. Okay, that's 0, 9, and this guy down here, that's 0, -9. So the value of C is 9. Okay, all right, so that's what this tells us. Right there, C is equal to 9. Okay, now the vertices are represented by A. So we're going to use this property that we just did in the last problem. If I subtract the two distances, I know that that's equal to the distance between the two vertices. So this distance is equal to 2A. Okay, 2A is the distance, this is equal to the distance between the vertices. Right, that 14 is the distance between the two vertices. And these vertices are on the y-axis. So that means A's got to be 7. So one of these is 0, 7, and the other one is 0, -7. Okay, so that would be these 2 points right here. That point and that point. Those are the two vertices. All right, now to find B, when we wanted to find B, we use this Pythagorean relationship right here. So I use that C² equals a squared plus b squared. Okay, we know c is 9 from the focus points. Okay, we know a is 7, the vertices, and now we can figure out what b is. 81 take away equals 49 plus b squared. Okay, subtract 49 from both sides, and I get 32 equals b squared. So if I take the square root of both sides, I get b is root 32. And what I wrote here is, for this, just leave your radical unsimplified. So what we just found was this distance right here is root 32, and that distance here is root 32. And so we write that down. One of them is negative root 32, and the other one is positive root 32. You don't need to convert it to a decimal. Okay? It's around 5.6 roughly. But you wouldn't write 5.6, just write the root, whatever it is. All right, then you got to write out the hyperbola. Okay, well, since this hyperbola has a transverse axis, okay, that is the y, that's your transverse axis. Okay, the form that I use is y squared over a squared minus x squared over b squared. So that's simply y squared. Okay, a is 7, so a squared is 49 minus x squared. B is root 32, so b squared is 32. And there's your equation. Okay. Good. All right, the next one for a test. Okay, so we got 5 terms. So my terms are going to be 2x, this is negative y. So in here I've got 2x and negative y. And 2x, negative y. Okay, now the exponents on this, the first term is going to count down, so 4, 3, 2, 1, 0. And the second term is going to count up, 0, 1, 2, 3, 4. And now to get the coefficients, we use our combinations here, or we use the digits, the entries in this row of Pascal's triangle. So the first one is the combination of 4, choose 0, which is 1. This one is 4, choose 1, which is 4. 4, choose 2, 6. Okay, 4, choose 3, 4, and then 4, choose 4, 1. And now we got to simplify it all. So our first one, we're going to have 2 to the 4th, 2 times 2 times 2 times 2, that's 16x4, negative y, 0. Next one is going to be a minus because negative y to the first is a negative. And I'm going to have 4 times 2 to the third. 2 to the third is 8. 8 times 4, that's 32. So this is 4 times 2 to the third. And then I'm going to have x cubed y. Okay, here the negative is squared, so it's not going to affect it. I'm going to have 6 times 2 to the fourth, or 2 to the second, which is 4. That's 24. So I got that by going 6 times 2 squared. And then x squared y. Here, my negative's got an odd exponent, so it's negative. 4 times 2, 8x y cubed plus, that's negative, has an even, so that's going to be positive. That's 1 to the 0, that's 1, so y 4. And there's my solution. Root of the modulus. And you're going to need the angle of rotation divided by 2. Okay, all right. So the first thing we're going to do on this is graph it. So this would be -3, -4. Okay, and there's our point. All right, now, the modulus of this is pretty easy. So the modulus is going to equal the square root of, that's A, that's B, so A squared plus B squared. So that's 5. So we did that. Okay, now you got to figure out what theta is. This is the one you got to kind of be careful with. All right, so to find theta divided by 2. Okay, so what we got, this is what theta is. Okay, so we want to figure out what that angle is. That's theta, and then we're going to divide it in half to get the square root of the complex number. All right, so we know that theta, the angle of rotation, is the arctan of B divided by A. So the arctan of -4 divided by -3, which is just +4/3. Okay, now be sure that you're in degrees when you do this. Okay, so I'm doing it on the Desmos calculator. I want to be sure that I'm in degrees. Okay, so degrees is showing, and I'm going to do see my arctan, and -4 over -3 is the same as just 4/3. 4 divided by 3. Okay, and it gives me 53 degrees. So what comes out of my calculator is 53 degrees. Now, that is not theta. That's what comes out of my calculator. So my calculator tells me 53 degrees. Okay, now, you gotta, before you can't, that's not your theta here. You have to think about this a little bit. All right, that 53 degrees, guys, what came out of your calculator is this angle right here. Okay, but we want the angle that goes all the way over to here. Right, so in this case, that's 53, which says this angle that's vertical to it, that's 53. So to get theta, I'm going to take 180 and add 53. So you got to know when you do this, you have to graph these so you understand where the angle is. So now I add those two guys up, and I got 180 plus 53. Okay, so add 180. Whoops, I did the wrong. I'm going to add 180. So let's see. Let's do that. 2, 2, 2, 3, 3, 1, 3. Okay, so now you can get half of it by dividing that by 2. 116. Okay. All right. Now what I'm going to do is my square root looks like this. So the square root equals the square root of the modulus times the cosine of theta divided by 2 plus I sine theta divided by 2. Okay, so I'm just going to substitute those in now. Okay, R is 5. Cosine, and this is going to be 116, 5, 6, dot, dot, plus I sine 116.56, dot, dot. And then you multiply those out. So I'm going to multiply the first two. Plus, and then I'm going to multiply the second two. I root 5 times sine. Okay, and when I do that, let's see, clear. So I'm going to go square root 5 times, whoops, I don't want that under the square root. Let's get rid of that, clear. Square root of 5, space, times, okay, and I want the cosine of 116.565. Okay, and if you look at it, it's equal to negative 0.99999. So this is really negative 1. Okay, and now when I multiply the other one out, root 5, okay, times sine 116.565, and that's equal to 2.00000, so this is going to be 2I. Okay, so that's one root. So my two square roots are going to be the square root of this is going to equal -1 plus 2i. And now take this and multiply it by -1, 1 minus 2i. And those are my two square roots. Remember, these should be opposites of each other. Not conjugates, opposites. So I multiply the real part by -1 and the imaginary part by -1. Okay, and all right, so people watching the video, I made a mistake on 7 because x should have been 2x, and I didn't put that in there. Okay, so I'm going to correct that, and I'll repost this here. All right, so the correction on this is now 2 to the 4th, 2 times 2 times 2 times 2. That's 16. X4, y, that's just 1. Okay, this is going to be minus because of that negative. So negative 4 times 2 to the 3rd. So 2 times 2 times 2, 8. Times 4, 32. X cubed y plus 6 times 2 squared. 2 squared is 4. 4 times 6, 24. X squared y squared minus, because of that odd exponent on the negative y, 8xy cubed plus y to the 4th. What's the solutions to this equation? First thing, there's a typo right here. So you're going to add a square on that x. Okay, and we want to find the roots to this. So we know that it's going to have 4 roots. All right, now this particular one, this kind of looks like a quadratic, okay? Because if this was, if it looked like this, u squared plus 14u minus 32, that's a quadratic, and I can factor that. That's something I'm used to doing. You know, what two numbers multiply together to be 32, negative 32, and at the same time add together to be 14? Well, that's negative, that would be 16 and negative 2. So this thing would factor into u plus 16 and u minus 2 equals 0, which is, and I know how to deal with that, okay? So we can use that to solve this. If I say, okay, I'm going to make that, this has got a power of 4, but if I say let the letter u equal x squared, then I could rewrite this. U squared plus 14u minus 32 equals 0. So I turned it into something that I know how to factor. Okay, now this is easy to factor. Right, so it's going to factor into those two things. Okay, and now I'm going to put the x squareds back in. So now I have this, u or x squared equals 16, or plus 16, x squared plus 16, and then this would be x squared minus 2, and that is equal to 0. Okay, now on the side of the room, guys, we have these two factor formulas over by the door. And one of those factoring patterns was a squared minus b squared. That's called the difference of two squares. And that factors into this. And the other one we got over by the door is this one. And that factors into this. So this right here, folks, is going to factor. I'm going to use this second formula right here. So to break that down, I'm going to use that. So A is going to be x. B is 4. X minus 4i. And then to factor this one, I'm going to use this pattern. And that is going to be x plus square root of 2, x minus root 2. And now there's the four factors. And you can get your roots from that. Negative 4i makes that 0. 4i makes that one 0. Negative root 2 and positive root 2. And there's my solutions. Now, okay, so if n was equal to 6, the 6 roots of unity, well, they're going to be located every 60 degrees. So 60 degrees, each one of these, there's 12 of them, so each one's 15. So there's 60 degrees. Then 120. Then I add another 60, 180. And then another 60, 240. And another 60, 300. And then I'm back to the beginning. So there's my 6 roots. So on this one, there's this again is the unit circle. This thing's got 8 roots, so n is equal to 8. So x to the 8 equals 1. All right, now, when you're doing this next one here, okay, this is your 6 roots, so it corresponds to the angles on your unit circle here. All right, so if I said, what's the location of point E? Well, point E corresponds to this angle right there. And the coordinates tell me what that is. That would be negative 1/2, comma, negative root 3 over 2. That's the coordinates of this point. Okay, now that point actually is right here. Because that's on the unit circle. So to get the point that is at E, I'm going to take this, when I write it out, I'm going to multiply it by 2, because this is on the circle that's 2, not 1. So this point right there is actually 1/2 minus root 3 over 2I, and the one that I want now is going to be 2 times negative 1/2 minus root 3 over 2I. So I just distribute that. And I get negative 1 minus root 3I. If it was one more out, then I'd multiply it by 3. So if it was all the way, like if I put it right there, that one would be 3 times negative 1/2 minus root 3 over 2I. So each time you go out, you're just multiplying. That's the new modulus. You're multiplying the coordinates by that modulus. All right, and the last two from lesson 6. These were when we did. What I have to do is I've got to convert to get the real form of this equation. I've got to convert cosines and sines into x's and y's. Okay, all right, so to do that, the x part of this equation, the real part, is cosine. So I can write that x is equal to cosine. Okay, the y part is 3 sine. Okay, the I just tells us that it was this axis here. So y equals 3 sine theta. Now I'm going to solve each one of these for x and y. So this is already solved for x. Okay, this one I'm going to solve it. I'm going to isolate cosine, it's isolated. I'm going to isolate sine by dividing both sides by 3. So sine theta is equal to that, and cosine theta, that one's already solved. Now the way I'm going to get these converted into x's and y's is I'm going to use the property, the Pythagorean identity, that cosine squared plus sine squared equals 1. All right, so I'm going to I've got to get this and make it into a cosine squared. So if I square both sides, I get that, and so what I can do is take this cosine squared out and put x squared in its place. And here, if I take both sides and I square it, I get y squared over 9 is equal to sine squared. So then I can replace that down here. So this would be y squared over 9 equals 1. So that is the rectangular form. That's the real form. Okay, so now to graph that, let's see, my major axis, that's going to be the longer one. So that the square root of that's 3. It's going to be along there. And then x, the denominator right there is 1, and the square root of that is 1. Okay, and now I'm going to draw my rectangle and fill in my ellipse. So that means that the major axis okay, so a squared is 25. So a is 5. 1, 2, 3, 4, 5. Okay. And then your b value, that's b squared. So b is 2. Okay, and in complex form, this would be 5 plus 2i. And then you're going to draw your ellipse. Yes. Is that the assignment?
Before, yeah.
Okay.
You checked today, but I need to go change my comments.
Oh, okay. All right. Let me finish this here. Okay. And then, let's see. And there's your ellipse.